All right, it's time to look at the last type of projectiles, which are still under the category of angled projectiles, but these ones don't end up back at the same level where they started. So they are brilliantly called not ground to ground or non-ground to ground projectile angled projectiles. So you'll often hear them called non-ground to ground. Okay, and all that means is that they end up either above or below where they started. And it could be either one. So it could be that you're on the roof of a building and you're kicking a ball upward at an angle and it ends up down here somewhere. And that would have been our football lab. We would have kicked footballs off the roof and they would have landed down on the ground and we would have timed them. Another possibility is perhaps you were standing at home plate and you hit a ball and it goes up and ends up in the stands. Okay? So in these cases, they're very similar, except in this one, the delta dy. So in neither of them will the delta dy be 0 anymore. In the first one, the delta dy is going to end up negative. It's going to be negative because it ends up below where it started. And in the second one, the delta dy, I'm just going to move the building to over here so that the delta dy is going to be positive because it ends up above where it started. Okay, so the delta dy is no longer 0. Just like in the ground-to-ground ones, the VI will be going up and the AY will be going down. And so again, we're going to have to worry about positive and negative, okay? So finding the time up is no longer useful in our life, finding the half time. Because you could find the half time, but then doubling it will only take you to like here and you'll still have all this section left. Or you could find the half time and then doubling it will take you all the way down to the bottom, but it's not all that time. So using our little trick that works for ground to ground isn't going to work here. Instead, we're going to use the quadratic equation to solve it, okay? And you will get 2 times. Usually, sometimes one time will be positive and one time will be negative. Sometimes both times will be positive. Okay, and so then you're going to have to think about which one will I need. Both times will be positive when the delta dy is positive, right? Because there's 2 times when it's at this height. Here, one's here, and one's here. Okay, but we'll come back and do that. So let's do an example. It's probably the easiest way. So we'll start with one coming off the roof of a building and going down. Okay, and so let's say that our VI is 20 meters per second, and let's say that our angle is 30 degrees, and let's say the height of our building is 200. That's really high. Is that really what I want? 248 meters. That's a high building. All right, so in the x direction, we have our VIX is still VI cos theta. Our AX is still 0. And the question probably asks, how long is it in the air and how far away did it land? So we're looking for delta dx and delta t. Okay, in the y direction, VIY is VI sine theta and it's up. AY is 9.81 meters per second squared and it's down. And delta dy is 248 meters and it's also down. Okay, so again, finding the time up is not going to be helpful. Instead, you're going to have to suck it up. We only have one unknown in the y direction. Suck it up and use the quadratic. You're in grade 12 now, you can do this. So delta dy is equal to VIY delta t, 1/2 AY delta t squared. I'd fill my numbers in if I were you before rearranging so that you don't mess up the negatives. So down is negative, so 248 meters minus is equal to 20 meters per second sine of 30 delta t plus 1/2 negative 9.81 meters per second squared, right? So it's a quadratic because you have a t squared term, a t term, and a whole number term. I would bring these 2 terms on the right-hand side over so that your t squared term is not negative. Half of 9.81 is 4.905, and it's positive when I bring it over. Sine of 30 is a half, so this becomes negative when I bring it over. 10 meters per second delta t, and the 248 meters stays as negative, equals 0. And now I fill it in my quadratic. So delta t equals b squared, so negative 10 meters per second squared, plus or minus the square root of negative 10 meters per second. B, there's no squared here, sorry, minus b, and the squared is here. I was just doing it in my head and it was like, where did that, there's the b squared. Minus 4a is 4.905 meters per second, and then c is negative 248 meters, and then the whole thing gets divided by 2a, 4.905 meters per second squared. Notice how I kept my units? Because they all have units and you should keep them. That way you'll know you didn't screw up your equation. Like if I had squared that, I would have ended up here with meters squared per second squared, and something would definitely be wrong. So minus a minus 10 is plus 10, plus or minus under the square root. This will be 100 meters squared per second squared. This negative and negative are going to be positive, and when you do the math, you get 9731.52 meters squared per second squared. On the bottom, 9.81 meters per second squared. So the total under the root is 9831, and then we're going to take the square root. So 10 meters per second plus or minus the square root is 99.15 meters per second, and then over 9.81 meters per second squared. So it's going to give us two possible answers. 10 meters per second minus 99.15 meters per second over 9.81 meters per second squared, or 10 meters per second plus 99.15 meters per second over 9.81 meters per second squared. Obviously, in this case, the top one is going to give us a negative, so we know it has to be the bottom one. 109 divided by 9.81, and that gives us positive 11.127 seconds. If you had done this one, it would be 89, and you get something like negative 909 seconds, and clearly it can't be. So once you have this, now you can take it, the part of the question asked, how long was it in the air, and the other part, how far away did it land? So once you have your time, then you can go delta dx is equal to vi cos theta vix delta t, and then the 1/2 ax, of course, delta t squared goes to 0. So delta dx is equal to 20 meters per second cos of 30 times this time you just found, 11.127 seconds. And you should get a delta dx of 192.72 meters. Okay? It might even ask you what was the maximum height it reached. But that one, and you can't just use the half time for that, right? Because half time is not going to be there. So I'm trying to, I said it and then I thought, or maybe not. I don't know that they will ask you that, so don't stress about it. All right, so homework tonight, page, it's going to be 9 to 12 on page 543, and it's all non-ground to ground. Okay? 9 to 12, what did I just say? 543.